Welcome everyone. In this video we are going to plot oscillatory signals in MATLAB. So we will plot three types of oscillations: increasing oscillation, sustained oscillation and decreasing oscillation. So what we will do is we will take one wave, one signal which is the sine wave. We will multiply with that sine wave with exponential signal for three different cases. The exponential signal is of the form c exponential power at, where c is a constant 2, and we have three different cases for a. For a is equal to 0, we will have sustained oscillation when sine wave is multiplied by c e power at with a is equal to 0. For positive value of a greater than 1, we will have increasing oscillation, and for negative value we will have decreasing oscillation. So let us start our code. First we will define the frequency for the signal. Frequency, I take it as 50. Then I will define the time period, which is the inverse of the frequency. This c I will make it equal to 2. Fine. And then I will go on and define my time range. So the time should start from 0 with the step size of t divided by 20, and it should continue till 40 times time period. So here we go. We have defined the value of the row vector, which is the range of t. Now we will have three cases. For case number 1, I will define a positive value. We want to plot an increasing oscillation. So I will define a is equal to 2. x1 I will define the same, which is sine omega t, which is, and omega is 2 pi f, so it is sine 2 pi ft. Fine. So this is my sine function, and this is my exponential function, which is c exponential. Exponential is defined as exp in MATLAB, and then I have a, which is 2 multiplied by t. Now this is x1 and this is x2. To get oscillation I need to multiply it, so I will multiply x1 and x2 using the dot star operator. So now x1 x2 has been multiplied. Now I will plot all these three. So I will use the subplot command with 3 cross 3 sub-regions, because I want to plot total 9 regions. I will define plot x1, give it a title. For example, title is sine wave. Fine, because this is x1, this is sine wave. Then at subplot second position, I will go on and plot x2, which is my increasing exponential, and I will give it a title exponential signal. Fine. And then finally at the subplot third position, I will plot the increasing exponential, which is x3, which is the multiplication of x1 and x3. I will give it as increasing oscillation IO. Fine. So now I will run that. Hopefully we will get increasing oscillation. I will save it. Yes, hopefully we will get an increasing oscillation. So here we go. We have a sine wave. Fine. Because the time period is very low, the frequency is very high, that's why it's difficult to visualize this sine wave. But when this sine wave is multiplied by this exponential signal, as we can have a look, we get an increasing oscillatory signal as defined here. The magnitude of this oscillation is increasing as time increases. Now we will go on and plot case 2, which was for a is equal to 0. So now we will plot for sustained oscillation. So again, y1 I will define it as sine wave. In the range of t will be same. So this is my y1. y2 will be again c exponential 80, but now my a is 0. Fine. And then y3 will be the multiplication of 2 to 2. So after plotting this, hopefully we are going to get a sustained oscillation. I will again do the subplot. Now I want to go to the fourth position, so I am going to plot t with y1. So this will plot me the sine wave again. Then I can give it a title sine. I will give it just sine, and subplot 3 cross 3 with the fifth position. I will plot t by y2 and give it a title constant signal r. So I can give it a title as constant signal. And then finally I can plot the sustained oscillation by in the sixth position using the subplot and the plot command. Plot sustained oscillation was my y3, so I will put in the comma, I will put it y3, and now I will give it a title sustained oscillation. Hopefully we will now have an increasing oscillation as well as sustained oscillation till here in the figure 1. Here we go, we have an increasing oscillation. This is position 1 in the subplot, position 2, position 3, position 4, position 5 and position 6. So this is constant oscillation. This is sustained oscillation because the magnitude of the oscillation is maintained. Now we will go and plot case 3. So in case 3 we have a negative value of a, which is for example -2. So then again I will go on plot sine wave. Let me define this sine wave again. So I will give it the name z1. So this is z1. Then I have z2, which is again the exponential signal, but this time I have a negative value of a, which means that this is going to plot me a decreasing oscillation, and then I will multiply z1 and z2 and assign it as z3. Now I will do the subplot part again. Subplot at position 7 I need to plot the sine wave again. So I will plot t comma z1 and I will give it a title again sine. So the sine wave is done. Again subplot 3 cross 3 and the 8th position I will plot what will I plot? I will plot the increasing exponential, which is z2. I will give it a title increasing exponential. Fine, I have given it a title. And finally I will plot the decreasing oscillation. So to do that I will say plot. So now we have the ninth and the final position, 3 cross 3. So ninth is the final position and I am going to plot z3 in it, and I will give it a title decreasing oscillation, or simply DO. DO means decreasing oscillation. So now I will run it. Hopefully I will get all the 9 parts. Here we go. So we have sine wave with the increasing. When this sine wave is multiplied by this increasing exponential signal, we have increasing oscillatory signal. Then we have sine wave multiplied by constant signal, so we have sustained oscillation signal. When we have sine wave multiplied by decreasing exponential, let me rename this. I have by mistake name it as I should name it as decreasing exponential. Fine. So I will run it again. So decreasing exponential, when it is multiplied by decreasing exponential, sine wave is multiplied by decreasing exponential, we get this decreasing oscillatory signal. Thank you.